That's pretty decent. Let's go. Okay. That's pretty decent. Let's go. Okay. That's pretty decent. Let's go. Let's go. Let's go. Okay, so I had my desktop audio in there as well. That's why I was looping like that. I'm glad I checked it. Okay. Alright. So let's get on Reddit. Put this over here. This side. Pop out the chat. Shrink it down like that. And then log in. And lately I've been enjoying the Cheat at Math subreddit better because it's just questions. Like there's not as many people answering them. I feel like intersection proof. Does this proof we're going to prove let U be the universal set and let F be the set of S of I such that I is in I, subset of U where I is some set. Okay. That doesn't make sense. No. Section I. Okay. First thing, sum of cosine, 1/2 mod cosine through pi over 2, through theta over 2 is a product of sine. Okay. So half angle identity, then we have the sum. Okay, according to witness for this further, sine is okay. not save? Documents maybe? Downloads. Pictures, desktop. No. Would it be a group, wouldn't it? Let me go settings, keyboard, shortcuts, screenshots, Control Shift, print screen goes to. It takes it to the clipboard, so we want to go copy screenshot of an area to the clipboard. Save, that's what we want. Boom, boom, boom. Replace. Alright, there we go. I had to reinstall Manjaro today because I messed something up with my camera, and then none of my stuff is like reset up. Let's go date modify, right? Yeah, that's what we want. Alright, here we go. And so even all my pens and stuff are gonna be off. Go ink. Yeah. Okay, so expressing the sum. Alright, so we've got this thing and we're trying to get it. This is not true. Okay, so you got it. I'm going to trust that this is true. -2 sine of theta times sine of theta over 2. Okay, so as a product of sine or cosine. And, you know, I don't even think this is what they want. Yeah, maybe. But let's just assume that this, oh, and I even have that wrong. This is -1/2. This is negative theta over 2. Okay, so that's starting from here, and it looks the same. So this is an odd function. The definition of an odd function is if you have f of -x, this is equal to -f of x. So that means inside here, in the same format, you know, f is sine. And then we can just say let x equal theta over 2. And then by that, you know, this, you don't need to write all of this stuff. This is the identity. I'm just writing it for you to understand what my argument here. Then this means sine of negative theta over 2 equals negative sine of theta over 2. So this thing is equal to -2 sine of theta times negative sine of theta over 2. That's by this here, and then negative times negative makes a positive. So you're super close. Now again, I want to make it clear that I didn't check your work up to that point. So, you know, if you feel confident about it, cool. If not, post something in the chat, because I'll go back and try to work that out myself. And I'm going to keep this layer just in case we need to work on that problem again, so we can bring that back. But I'm going to go find another one. That's a good question, though. Very cool question. Having issues with the overall problem. Can't seem to solve it. Been stuck on it for a couple days now. Would appreciate an inside picture. Let's see this problem. Okay, part 1. Use the given information. Okay, I can probably do this. 2 hours old. Nice. Working on no problem in my live stream. Yeah, I used to. Where's the time though? 11 minutes. I used to be like, oh, you know, your problems at this time, but then I had to start like basically saying like, oh, I'm working on it at this time, because there were so many times where I just couldn't solve the problem, which is cool. Like there's nothing wrong with that, but at the same time, people don't want to watch this whole video and find out like at the end that it didn't get solved. Although, I think maybe some people find that valuable. Okay. So sorry if this looks kind of funny. I didn't take a very good screenshot there. And, alright, so part 1. Use the given information about angles alpha and beta to find the exact value of sine alpha minus beta. Alright, cool. So let's go with the identity. So this is sine alpha minus beta. What is this? So it's like sine alpha cosine beta minus cosine alpha sine beta. And I'm going to actually check that so I don't start this whole thing off. So sine difference. Okay. Yeah, alright. Look at me with the memory. Okay, so then this is the value we want to find, right? So all I'm going to do is I know sine A, or sine alpha, cosine beta, and then we'll find the other ones. Then there's other important information here that this is alpha is between pi and 3 pi over 2, which means it's in the quadrant 3. Well, no, that's 4. Not good at the nomen numerals. And then b is in 3 pi over 2 to 2 pi. That's 4. Okay, so let's draw a little picture so we can understand what's happening. And then I'm going to make a layer so I can draw on top of this. So basically we've got alpha somewhere in quadrant 3. Alright? And that's not to scale or anything like that. I'm not even going to try. So this is alpha. Then let's do like a nice purpley bluey color. Yeah. This is going to be beta, which is in the 4th quadrant. And so this is beta. And we don't know what the radius of this thing is, but no matter what, if you assume that the radius is 1, you'll be fine. Okay. So the sine of this thing is 3/5, negative 3/5. Now, oh wait, is that possible? Yeah, my bad. Okay, so then, matter of fact, I'm just gonna go here. Okay, so we construct a triangle, right? And we know that sine is negative 3/5, so y is negative 3, hypotenuse is 5. You can use Pythagorean theorem, a squared plus b squared equals c squared, to find out that this is 4. And it's a 3, 4, 5 triangle, that's how I knew. So that means the coordinates of this point are negative 3, 5. I'm sorry, negative 3, 4. Oop, backwards. 4, negative 3. So this is the x and this is the y. Okay, so we're going to do a similar process for the other side. So let me grab this purple. And then I'm going to construct a right triangle there. same thing. So this is cosine of b. So we've got 12 over 13. And I'm just going by the definition of cosine, right? So it's like x over r. And so 12 is the x, and 13 is the radius. And then since it's in the fourth quadrant, y is going to be negative. So we just need to figure out, like, let's call this y for a second. 12 squared plus y squared equals 13 squared. And that's what I did with the other thing. I just know 3, 4, 5 is a right triangle. And you do too now. So don't really trip about that. So I'm going to subtract 12 squared from both sides. And so it's 13 squared minus 12 squared. 13 squared is 169, and then 12 is 144, and that difference there is 25. So y squared is 25, which means y is either 5 or negative 5. And you can tell it's negative 5 because it's in the fourth quadrant, and that's the y coordinate of this point. Negative 5. Okay, so why did I do that? Because I've got sine A, cosine B, which is what we're given, but then I need cosine of A and sine of B. Now I can actually calculate those things. So let's take the given that we got sine A equals negative 3/5. Oof, that's not good handwriting. Negative 3/5 times cosine of B, which we're also given, is 12 over 13, minus cosine of A. You gotta be really careful because sometimes this is negative, and you run into double negative issues if you don't like substitute into parentheses, right? That's really important. It's going to save you so much heartache and like time doing recalculations and points off on tests and all that nonsense. So let's look at that. Alpha. So alpha is the angle we're talking about now. Cosine is x over r. So x over r. But it's really important to realize that this is actually negative 4 because it's in the left side of the y-axis. It's in the third quadrant. So we've got negative 4/5. Sine and cosine are negative in that part of the unit circle. And then sine of b, so now b, we're dealing with b now. We want the sine, so we want negative 5 over 13, y over r, or whatever, y over the hypotenuse. So we'll go negative 5 over 13. Okay, now this is like, some number here. So let's multiply everything together. So this is negative 36 over 50 plus 15 is 65. And then negative, negative, negative. So 3 negatives makes this product negative. And then we got 4 times 5 is 20. And then 5 times 13 again is 50 plus 15 is 65. Negative 36 minus 20. It's going to give us negative 56 over 65. And then, so this is going to be like, what, 5 times, we already know this is 5 times 13. We know what the product of that is, right? We got it from here. So I know what the factors are there. It's 5 times 13. Does this have so all you have to do is check, is this got a factor of 5, does it have a factor of 13? If it's got neither, you can't cancel, because that's the only factors it can cancel with from here. So it doesn't have 5, obviously. It doesn't end in a 5. Let's check 13. 13 times 3 gives us 39. 4 gives us 40, 52. And this is 56, which is not 12 more than that, so we're good. This is irreducible. That's the answer to part 1. And then, so now if we just look down at this is the same sine. That's the same interval there. It's in the same quadrant. Same cosine. Same interval. So these are the same angles. And it's again the same down here as well. Okay, so basically we're just going to work with the same angles, which is really cool because we don't need to figure all of this out again. That's just going to be the same. So what we want to do now is use the cosine double angle identity. I'm going to go ahead and, well, let me erase this. It's not cool. Go eraser. Sorry, I just got to change my eraser. Size. I don't want to change the size. Don't want to change anything. Brush tip, circle, diameter, boom, no fade anywhere. Good. Yes. I didn't save it. Save. Copy. Yeah. And then assign tag my favorites. All right, there we go. Let's go. Hopefully I won't have to do that again in a live stream. And then what was my last brush? I want the tech pen. Ink. Yeah. Favorites. Is that my guy? Yeah. Okay, so same thing. The first time they asked us to find this one, in part 2 they asked us to find the double angle for cosine. So 2b. And this is going to be sine, cosine plus cosine sine, but they are the same, so it's 2 sine beta, cosine beta. Right. No, wrong. Let me check that. Yeah, okay. I knew this wasn't right. Because it's cosine times cosine minus sine times sine. Well, there's actually a bunch of these. Well, we can use this. Cosine squared beta minus sine squared beta. Yeah. And then you can get 2 others from these using the Pythagorean identity for like cosine squared or for sine squared. Just whatever you want to do. All right, so this is going to be, anyway, that's the answer for the first one. This is going to be, so we know cosine of beta is 12 over 13. And we're going to square that because we want the square of it. And sine squared of beta, what did we say sine squared was? Or sine was 15 or negative 5 over 13. Negative 5 over 13 squared. This is squared, so you know it's going to be 144 over 169 minus negative 5 squared is 25. 13 squared is 169. So this is going to be 2419. So 119 over 169. I know the only factors of this are 13, right? It's 13 squared. I know that from up here. So all I have to do is look for a factor of 13 there. And how am I going to do that? I'm going to minus 26 from this. No. I need more than that. I need 39 maybe. It's definitely 50 less. Okay, so 169 minus 50 is going to give us this. And I know 50 is not a multiple of 13, so this is irreducible. That's lowest terms. All right, last one. So this is part 2. Let me write that. Part 2. Part 1. And then I'll just keep the green here. All right, so we got, so same information. I'm just going to keep using this because it's the same angles. We need the sine half angle of beta, which is going to be, what are we going to do with that? We want, it's going to be, really you should know these, but I'm lazy so I don't know them. Yeah, alright, I do know them, but I just never trust myself. So this is either positive or negative, and just hold on to that for a second because we have to determine if this is positive or negative using our, just thinking analytically after that. And I always hold that off to the end. Cosine of beta over 2. Okay. So then, what are we going to use here? And you can always get these from this. Like, you could derive this from there. As long as you know this angle, you know the half angle too. Because, let's say, here's beta. You just make this 2 beta equal to some other angle theta, and then beta equals theta over 2, right? So now these are half angles. But you can write cosine in terms of sine or sine in terms of cosine. So So you can just get this thing over again. So no big deal. Then what are we going to do? So let me get rid of that so I don't confuse anybody. All right. Then we want 1 minus, so it's plus or minus the square root of 1 minus cosine of beta, which cosine of beta is given to us as 12 over 13. So it's 1 minus 12 over 13 all over 2. So I'm just going to simplify underneath this radical here. Plus or minus, which we'll determine at the end. So 1 is the same as 13 over 13 minus 12 over 13 over 2. And 13 minus 12 is 1 over 2. And it's important when you have this like different sized fraction bars to keep the like the big one, and the little one. So this is the little one, and this is the big one. Because that tells you the order of priorities. It's like this divided by this. And then people make that mistake a lot. So this is 1 over 26 square rooted. And then let's just rationalize this. This is the same as the square root of 1 over the square root of 26, plus or minus, obviously. The square root of 1 is 1. Still with the plus or minus. And then we can multiply that by 1. Somebody check me, make sure that's 1. And this will be rationalized. So we'll have plus or minus root 26 over 26. So that's the answer here. Now we just have to figure out, are we positive or negative? So let's think. This is the sign of half beta. So we know that beta is in the third quadrant, and so we have to take half of that. But we don't know exactly where, right? We know beta is less than 3 pi over 2. And, oh no, it's in the fourth quadrant. So it's greater than 3 pi over 2 and less than 2 pi. So it's somewhere over here. So let's imagine it's like just a little bit less than 2 pi. What's half of it? Okay. Half of 2 pi is exactly 1 pi, but it's less than 2 pi. So it's got to be this side of pi. And then let's do half of 3 pi over 2. Okay, that's the other extreme. So it's definitely on this side of 3 pi over 2, but we need to take half of that. So half of that would be 3 pi over 4. So here's 1 pi over 4, 2 pi over 4, and then 3 pi over 4. So it's somewhere greater than this. So it's in this range. And it's like not equal to either of those numbers. Okay. So basically, how you can figure this out, like analytically, this is kind of an aside, is I know that 3 pi over 2 is less than beta, which is less than 2 pi, right? So I'll divide all sides of this by 3, or by 2. So I get 3 pi over 4 is less than beta over 2, which is the angle we care about now, which is less than pi. Okay, so I divided everything up here by 2. And that's what we just thought through graphically just now. So then we know that our angle is in this little like region here is sign positive or negative there. It's positive. That's the second quadrant where sign is positive because it's a y. The sign is the y. So this is the positive, which means this whole time it was positive. I just waited until the end to figure it out. So we'll just leave the positives everywhere. You could do this at the beginning too. Totally up to you. Yeah, so that's the answer to part 3. Let me know if there are further. I'll keep all of these, but let me know if there's further questions on that. Go back to this. Did I even post it? I didn't even let him know. Did I not? Yeah, I didn't. Smart guy. Oh no, I did. All right. Okay, what are we doing? People, no new questions, huh? Help IEEE Standard 754, please show steps. What could that be? No thank you. Engineering questions. Can someone please help me with these? Badly need help in samples. Alright. Sketch the graph of the following 5 sets. Okay, this was like a whole day ago. Yeah, this is not a good question. Whoever you are, shame on you. I mean, shame on the teacher for asking this question, but shame on the student for like. I feel like this is kind of opposed to how I normally approach these things, but you're in trouble if you don't have some kind of an attempt at this. Because you got to do this on a test probably, And like I said, normally I don't even get down on people for that, but working on your problem in live stream starting at how many minutes? 32 minutes. Yeah, you need to if you're like not able to start this, you got to get help, and probably not from your teacher. Don't ask your teacher for help, because your teacher got you in this mess. All right, let me just bring this over here. Import, and there she is. Okay, sketch the graph of the following 5 sets of abscissa and ordinate for each. 5 set of abscissa and ordinate for each. Okay. All right. Ridiculous. So the first thing is circle. So this is like A. All right. Circle with center at the origin. And so I'm going to draw some axes there, and boom. I had a student recently do a test on graphing trig functions, like periodic functions, and do everything correctly, but forget to put this and this on there on every problem. So he lost 2 points for every problem and got a 50%, even though it was 100% correct. So put that on there. Then, all right, so the first thing is we want a circle centered at the origin. So I'm just gonna draw a circle, boom, centered at the origin. This, let's call this like, I don't know, R. Where the distance from here to here is R. Incidentally, it's also this because it's centered at the origin. But anyway, the radius is R is what this says because it's centered at the origin. That is going to be, oh, this is like 1A. That is going to be x squared plus y squared equals R squared. And then let's do 1B. So same thing. Draw some axes. I'm going to draw these smaller because I don't want to run out of too much room here. Not going to forget to label our axes. I got some points off that, on a test one time because of that. So let's call this point HK. And then we're going to make our circle centered it there. Ah, come on circle centered there. This value is going to be h plus r. This value is going to be, oh no, I lied, k plus r. This value is going to be h plus r. And then we're going to write the general form of the equation, which is the square of h minus k, I'm sorry, x minus h squared plus y minus k squared equals r squared. Cool, number one. And definitely if you posted this question and you pop in here, like, let me know how this is going in the chat. Like, say something. So if I miss anything that you need to know, like, I'll help you. I'm not just trying to do problems. I'm trying to help people. Okay, parabola. So, right, this is 2 now. Oh, look. Anyway. Alright, 2c. 2c. Vertex, HK opening upwards. Alright, so we got axes. We're going to go x, y. Always got to label them so you don't get a 50% on your test. And then we want this one to open upwards. I'm going to give it, a vertex here. And I'm going to sketch a parabola, and it's going to be horrible. Yeah. Which reflects how much I care about my ability to draw parabolas. Right side's pretty good. Left side's bad. So, anyway, this is the vertex. Kind of didn't look like it. HK. Boom, boom. And then, so a normal parabola is like f of x equals x squared. Right? So we actually want to shift this thing to the right by k and up by h. So if you think about how transformations work, this is like, oops. Ooh, that was wild. Let's say that, we're trying to make that function, which is g of x, is going to be, you shift f to the right by k by doing that, and then up, or no, to the right by h, and then up by k. And so what would that be? That would be like x minus h squared plus k. And that's actually the function that we're looking for. So you don't need to write all of that. I just wrote that to help you understand how I formulated it. This is also actually happens to be the general case of, or the vertex form, as it were, of almost exactly of the quadratic polynomial, or let's call it a parabola for now, whatever. But the full thing would be like this. You could have some coefficient out front of here. For ours, it's just 1. So I'm going to make it y equals x minus h squared plus k. And so that's the graph of that. And then let's go to D. It's going to be opening downwards now. So the same thing, we just want a negative coefficient out front of that. So it's going to be the exact same thing, but with a negative coefficient. And that causes it to go downwards. All right, boom. Label our axes. And we want it to open, terrible. We want it to open downward. And it's close enough. So yeah, again, this is point HK, and we're gonna go y equals negative 8 x minus h squared plus k. The reason why this works like that, it's probably more recognizable if you put it like this. So it's minus there and minus there. And you can see that same thing echoed here and here. It's like minus the thing. But if I just add this over to the other side, I get this version up here, which is typically how you see it. So ignore that. I find it easier to memorize the second way I wrote it, the one I just erased. Okay, so then 2D now is opening to the left. Okay, so if it opens to the left, that means the part that's squared is actually the x. So this is 2e. Alright, so normally if you did like x equals y squared, it would be opening this way. Oops. So we're going to need to multiply y squared by -1. And we also want it to be at the point hk. So let's think about this. We want x is, how are we going to do this? So I think this is going to be like x equals, oh no, I didn't even listen to the instructions. We want it to open it this way. Okay. But normally, if you don't multiply y squared by negative, it gives you that. Or we can multiply x by negative. It doesn't really matter. All right, how do we want to do this? So we're going to go x minus h gives us y minus k squared, and then one of these needs to be negative. I'll just put it there. But let me think about this, because I want to make sure that I have everything right here. Because I might actually want to switch the k and the h. Yeah, this is right. And I'm going to graph this on Desmos just to be sure. That's correct. Yeah, basically I graphed that on Desmos just to make sure, because I didn't want to make a mistake with that. What else do we got? Average watch time, 2 seconds. That must have been me. I think I'm doing this too late. Everybody's asleep. Yeah. Okay. Conic sections. So fun. I think this is my last problem. I'm getting tired. 3G. So we want an ellipse. Ellipses look really similar to the circle. So it's like x minus h squared plus y minus k squared equals r squared. So that's the circle. If you just divide this by, or no, I'm sorry, this is equal to 1 squared, if you will. But anyway, this is divided by a squared and b squared. And then depending on how you think of this, like you could switch these depending on what's the major axis, or you could leave the letters that are the same. It's just an ordering issue. Like if a squared is greater than b squared, this tells you one way the major axis goes, and if it's b squared is, if a squared is less than b squared, then the major axis goes the other way, which I'll try and draw for you in a second. I just want to convince myself that I'm correct before I tell you the wrong thing. So Desmos. And so we'll do h minus k, or I'm sorry, x minus h squared plus y minus k squared equals 1. And we want this whole thing to be divided by, no, that's not what we want this whole thing to be divided by, say, b squared. And this whole thing gets divided by a squared. I'll make sliders for everything. So first thing I'm gonna do is change okay. So basically the idea is whichever one of A or B is greater, that tells you the major axis. So if this is bigger, that's the major axis is on X. If this is greater, then the major axis is on Y. And the square is what I'm talking about. So let me draw this one. We're going to have some axes. X, Y. And then let's call this HK. And then I'll make an ellipse here. Actually, I'm going to kind of make it obvious what the major and minor axis is. So it wants to be like pretty squished. Okay. So then let's give a couple of values. We got that one, and we got this one. So, these are our major and minor axis. This is A, this is B. Yeah. Oh, let me change the color of this. Okay. Yeah, so that's this here. And then we'll go A, B, C, D, F, G, H. And it's going to be the same exact thing. We're going to have x minus h squared plus y minus k squared. So it's very similar to the circle, only you're going to put it equal to 1, which is the same as 1 squared, right? And then over a squared over b squared. Now, right here, for this first one, a squared is greater than b squared. But for this one, we're going to have b squared greater than a squared. And that's why our major axis and minor axis are going to switch. We've got some arrows. My physics teacher was very particular about these labeling your axes correctly, because a lot of like scientific like literature doesn't have those axes labeled correctly, and so then you can't determine what the graph is about. I mean, you can usually tell, but that was her particular pet peeve. And then I'm very cavalier about that. Like, I don't really care, because that's what I'm like tutoring. That's not my main focus. Is I'm doing this wrong. That you can label axes. I'm trying to figure out, or like, can you put the scale? Not can you put like X and Y there? It's usually pretty commonly accepted. That's what it's going to be. But I recently had a student lose so many points on a quiz that now I'm just like gonna say that constantly. Okay, so this is gonna be A, and then B. Yeah. And then so put these like somewhere on your paper so that they can tell what's going on here. Okay. What's the next one? Hyperbola is probably hyperbola. With center at HK, horizontal transverse and vertical transverse. All right. So the difference between this and ellipse is that there's a minus in between. And then let me set the origin. And then, yeah, so that's that. And then B. How does this work? Right, okay. So let me, so this is for I and J, right? So let me just first have a discussion about this. So you have like this graph, and a hyperbola is this like shape kind of like this. I don't know, my drawing's bad, but you get the idea. And this is the transverse axis, right? That's the transverse axis. So where that is determined by like which term is negative in the sum of those like squares. Yeah. Or I should say which one is positive. So if the x minus h squared is positive, then that's your transverse axis. If the y minus k squared is positive, that's your transverse axis. So let me just kind of do these problems. All right. And does it want it to be centered somewhere in particular? HK. Alright, so let's say this is HK. This one's kind of hard to draw, so sorry in advance. Then, how do we want to do this? So let's first do the horizontal transverse axis. So we're going to have x minus h squared over a squared minus y minus k squared over b squared. So it looks very similar to the circle, only this is negative. One of these terms will be negative. Then I'm going to try really hard to draw this, but oh, that's not bad. It should be symmetric though. It's pretty good. And then, boy, oh boy, that's pretty. Ooh, oh, who drew that? Some really nice guy who helps people out with homework. And then, so like, this is gonna be distance from here to here is A. And then, how does the B work for this? Let me go. Minus, and then what does B? So B kind of like, as it increases, it like vertically stretches the thing. But I want to make a point on this. Let's go H plus B plus A. K plus B. That's not right. How would that work? So it'd be like, that's A. It'd be like square root B squared minus H. Let me just look this up. So, hyperbola standard form. Oh yeah. Well, all right, whatever. That's fine. Yeah. So that's what I. This is like the point H plus A comma K. There's whole like hyperbolic trig functions which I'm like not very well versed in. So this is I and then 4J. So with this one, what we're going to do is make the other term negative. And so by making the other term negative, so it's going to be negative x minus h squared over a squared. And actually, let me just. I want to do something real quick. Make this positive, this negative, and then let's go with B. Yeah, alright, we're good. Y minus k squared over b squared equals 1. So, same sort of shape. It's not like a parabola. It's a little bit different than a parabola, but it's dished like that. Or let me call this HK. So we're going to do that's pretty decent. It's not as good as the other one, but whatever. This shape is like if you hang a rope between 2 points horizontally, it'll make this shape. That's the shape we're going for. Like if you hang a rope between 2 points, a string, you know, an ideal string, if you will. And so if you imagine I'm drawing, that looks more like a parabola than a hyperbola, but it's gonna have to do. Then I'm gonna draw from here to here. That is B. Okay, that's the whole thing. And why don't I kind of zoom this out a little bit? I don't know what kind of device you're gonna be watching this from. If you're watching this on a big computer screen, that'd be better. Let me give you an opportunity to screenshot, and then I'll zoom it, and then actually let me take it in 2 chunks. So all right, there's that. Screenshot that, and then screenshot that, and you should be able to work on that after if you need to. I think I'm done for the night. I'm exhausted. And I was told I could only go an hour. Oh man, 4 playbacks. Somebody came in and said what's up. Or it didn't say what's up, but came nonetheless. So thanks for coming to watch the thing. This is like 10:50 when they popped in. And oh, I guess you can't really tell. Alright, whatever. 4 playbacks though. It looks like they restarted their problem a bunch of times. So that's cool. Maybe other people will watch it tomorrow. But yeah, it's been fun. Y'all have a good night.